Okay, so true or false? Any two finite groups with the same number of elements are isomorphic. So, if we recall, a mapping F from H to J is isomorphic provided that number 1, F is well defined. Number 2, F is homo, and the important part are the last part. Number 3 and 4, F is 1 to 1 and F is on 2. And if we can satisfy these last two conditions, F is 1 to 1 and F is onto, then we can imply that the cardinality of H is equal to the cardinality of J, or they have the same number of elements. So, at first thought, if we answer this statement, we say that it is true, but actually the answer for this is false. And to show this, the best way to disprove this statement is to show some counterexamples. So the idea here is if we have a function, a mapping f, no, a mapping f from h to j, if a is a subgroup of uh, h in the domain, then f of a must also be a subgroup of J in the image. So this would imply that uh, the number of subgroups of of H and G are equal. So they have the same number of subgroups. So now let us consider H be the Klein-for group. If you don't know the what is a Klein-for group, then you can search in the Google what it is. So the Klein-for group, or V, has four elements, namely A, B, C, and E. And let us consider J as the Z4. So Z4 has also four elements, 0, 1, 2, and 3. So as you can see, the cardinality of H and J are equal, which is 4. So we can observe, or you can verify that J, or the Z4, has three subgroups. Namely, number 1, Z4 itself. Z4 is a subgroup of itself. Number 2 is the subgroup generated by 2, which has elements 0 and 2. And lastly is the the subgroup generated by the identity, or the identity itself. The identity is a subgroup, and the Klein-for group, or V, has five subgroups. Namely, number 1, V itself. Number 2, the subgroup generated by A. 3, the subgroup generated by B. 4, the subgroup generated by C. And 5 is the identity alone. So A has two elements, A and the identity element. Same with B and C, which has elements B and E. and C has elements C and A. So as you can see, Z4 has 3 subgroups and the V or the Klein-4 group has 5 subgroups which are not equal. So this would imply that this statement is false. So in the next video, maybe we can show to you that if two finite groups are isomorphic, then they have the same number of subgroups. So that's all. Thank you.